Good evening, my warriors. Welcome to the circular motion problem solving session with your favorite captor Shreyas. And today we are going to see some amazing problems on circular motion, which also involves Newton's laws, kinematics, and also work power energy. So let's get started. And those of you who do not know me, I am Captain Shreyas. I'm the physics master teacher, and I have been nurturing and taking care of kids, for a very long time. And over this tenure, many of my students have not just aced JEE and not just got into IITs, but they have got really amazing ranks. So many of my students got 2-digit All India ranks, and I am here on YouTube with the hope that you too will excel, you too will get into IITs, you too will be motivated for studying physics. So let's get started. And to motivate you further, I also have some really cool facts. Like this year alone, there were more than 1,500 students who cleared the JEE Advanced examination from Vedantu alone. And it's not just in JEE examination. You name any CET, you name any board, CBSE board, be it ICSE board, you'll always find Vedantu students. So I'm pretty sure the moment you enter into some graduation college, you're going to find your friends who will be probably, ex-Vedantu students. So probably that's something which you should feel definitely proud about. And to make this bond real strong, and if you are really motivated by these results, and if you want to really, study under us, there are lots and lots of ways to do that. And one of the way is the pro subscription, wherein at very affordable prices you get the crash courses, the specialized batches, the micro courses, the doubt solving, the material of Vedantu, which is the Tattva module, as well as guidance, strategies, and all such important sessions, along with assignments, tests, notes, everything. So it starts for as low as 1,350 rupees per month, and when you use my discount coupon code SHHPRO, you get that offer activated. So do check out the link which is there in the description box below. So are you warriors ready? Do let me know in the chat box. I hope you're all excited, and if you're new to the channel, do not forget to do one small favor: hit the subscribe button, and also do not forget to hit the like button. So let's get started, my warriors, and here is the first question on your screen. So what do we have here? How many revolutions per minute must the apparatus shown, which is over here, make about the vertical axis so that the chord, which makes an angle of 45 degrees with the vertical, is able to maintain that angle? What is the tension in the chord? Length is given, this distance A is also given, the mass is also given. Now this looks very similar to a conical pendulum. In a conical pendulum, you had a string which was pivoted at the top, and you saw that the conical pendulum went around like this in a uniform circular path. The only difference over here that I can see is there is a rod, and to the rod there is a thread attached, and that rod is rotating, and you can see the thread bends away from the axis. So it goes like that, and it is going around a big circle. Probably this reminds me of those fun rides, in those adventure parks, or probably in some nice gaming arena or area where those kids sit on the horses and the camels and God knows what, and when the thing rotates, it's like a merry-go-round. All these horses, zebras, God knows, donkeys, they start flying around, and this reminds me of that. So let's just try and solve this question. So obviously we need to start with the free body diagram. Let's start with the free body diagram, of course. So this point mass over here will obviously experience a weight. So that is going to be mg, like this. So this is, you can see over here, it's marked mg. Obviously there will be one tension over here. These are the only two forces acting on the mass. Apart from that, there must be some acceleration which I need to show. That's when your free body diagram is complete. Since it is going in a circular path like this, the center is over here, so there must be a centripetal acceleration. So I'm just going to mark the centripetal acceleration over here. The centripetal acceleration is this way because this is the center of the circle. Great. The only thing left is, what is this radius r? Because I think I will need that when I calculate the centripetal acceleration. So here is what I think. This r will be composed of two parts. One part, do you see this one over here? This A plus this much part. So r is A plus this much. Now how much is this much? You can see this triangle over here, this right angle triangle. L is the hypotenuse. You can see this is the base of that right angle triangle. So it's that base plus this A. So very clearly r is nothing but this length, which is A, plus the base of that right angled triangle. So what is that base going to be? Think about it. This angle is 45. This base is opposite to 45. So sine of the hypotenuse. So L sine 45. So it will be L sine 45. Now, do I know the value of A? Yup, it is given to be 100 centimeters. That means it is 1 meter. L is the value of L given to me? Yup, it is root 2 meters. So root 2 will come on the top. Sine 45 is 1 by root 2. Sine 45, cos 45, all are 1 by root 2. Root 2 goes 1 plus 1. That's going to be 2 meters. So the radius of the circle is going to be 2 meters just by pure geometry. We have not even used any physics till this point. Is that clear, my warriors? Let's move ahead. Now, think, what is the force which is giving that acceleration? Is it tension or is it mg? The answer is, mg obviously is not going to give this acceleration because it is anyways perpendicular. But tension entirely will not provide the acceleration. A component of the tension in the x-axis will give it, because the other component will be just balancing mg. I hope you can see that. So in fact, if I had to split the tension, I will split it into two components, one over here and one over here. This angle is 45. So obviously t cos 45, t sin 45. Cos and sine both are 1 by root 2. So t by root 2, and this is also going to be t divided by root 2. Both the components will be equal for sure, just because it is 45 degrees. So t by root 2 and t by root 2. So hence this t by root 2 will give the acceleration. So let's write it down. So net force, okay, will give you mass into centripetal acceleration. That force in that direction will be t divided by root 2, will be m into centripetal acceleration. I can just write it as omega square into r. That's one equation. In the y-axis, all right, this was in the x direction. So in the y direction, you will see that the net force must be 0 because there is no motion in the y direction. So there is no motion as such in the y direction. So hence t by root 2 should be equal to mg. And do I know the value of m? Yes, m is 5. Interesting. Do I know g? G is, let's assume it as 10. Okay, so t by root 2 is 50. Therefore, tension will be 50 root 2 newtons. So this is the answer which I needed, but that was the second answer. So what is the tension in the cord? I just figured that out. So the only thing left is the part A, which is finding the number of revolutions per minute. That means angular speed. So let's move ahead with the angular speed, my warriors. Since I know the value of t by root 2, from here, I will just substitute it over here and see what do I get. So this is going to be equal to 50. M is going to be 5. Omega square, I do not know. Radius, I just figured it out to be 2. 5 2s are 10. So therefore, omega square is going to be 50 divided by 10, which is nothing but just 5, units. Now from this I'll get omega is equal to root 5, but this will be in radians per second. I do not need the answer in radians per second, I need it in revolutions per minute. Be careful about it. So we all know that if this is root 5 radians per second, frequency wise this is root 5 by 2 pi, this is revolutions per second. This is in hertz. But again, I don't want it per second, I want it per minute. So if these many revolutions happen per second, So how many revolutions will happen in 1 minute? 1 minute has 60 seconds. So if these are per second, so I just need to multiply this with 60. So root of 5 divided by 2 pi into 60. So let's see what and all gets cancelled. This will become 30. Interesting. So this should be nothing but 30 root 5 by pi revolutions per minute, or RPM, whatever you want to call it. So that's your final answer. So this is answer A, this is answer B. So it was all about geometry, forces, their resolution. X force gives acceleration. There is no motion in the y direction, so y forces cancel. And just when you write those equations, you can solve it by simple basic algebra, nothing else. And you have to pay attention to the question what is asked. Since number of revolutions per minute was asked, so the first task was to find omega, but that was radian per second. Then you found revolutions per second, and then finally you found it revolutions per minute. So that's the flow of the problem. I hope you enjoyed this question. Moving on to the next one. Okay, so those are the answers. Here we have our next question on non-uniform circular motion. There is a point P. It's moving in an XY plane, like you can see over here. And it's moving in the counterclockwise direction. It's a circular path. The motion of the point P is such that it sweeps out a distance which is a function of time, which is t cube plus 5. So as time progresses, this s value will change. And you can see it's not a linear function, so you cannot use kinematic equations. Acceleration won't be constant. So it's something related to calculus, where s is the distance in meters and t is in seconds. The radius of the path is 20 meters. The acceleration when t is equal to 2 seconds is how much? Okay, so clearly, since I know how much distance is this particle traveling, okay, this is s, ds by dt, the rate of change of s will give me the tangential velocity. Isn't that right? So let's just figure out what is the tangential velocity. V tangential will be just ds by dt. How much am I covering along the circumference? That rate of change of length along the circumference will give me velocity along the tangent at any instant. So it will be derivative of t cube plus 5. Now t cube's derivative will be 3t square. 5 is a constant, so derivative will be 0. So this is the tangential velocity. So what do I do with this? Let's think. I need the acceleration at that point. If I want to find acceleration, then centripetal acceleration formula you all know, it's v square by r. Okay, so let's use that, but let's first find velocity at 2 seconds. So that will be 3 into 2 square. 2 square is 4, 4 3s are 12, so 12 meters per second. From that, the centripetal acceleration will be, which is velocity at 2 seconds square divided by the radius. So this will be 12 square divided by radius. The radius is 20 meters. 12 square is 144. 144 divided by 20, that's going to be 72 divided by 10, which is 7.2 meters per second square. Now you will quickly see 7.2 over here, and you will be definitely tempted to mark option C. But let me tell you, surprise, surprise, that's not the correct answer. Reason, please try to understand, in this question, the velocity, or rather the speed, is not constant. You can see it's a function of time. So you might have found the centripetal acceleration. Okay, you might have found the centripetal acceleration, but I'm pretty sure you forgot about the tangential acceleration, because this velocity is not constant in magnitude. So definitely when the speed changes, there must be tangential, and the total acceleration is the vector sum of centripetal and tangential. So most often students forget either centripetal or tangential. So remember, both kinds of acceleration are there. Only in uniform circular motion, the tangential acceleration becomes 0. Keep this in mind. So let's figure out tangential acceleration. Now the formula for tangential acceleration is very easy. Tangential acceleration is rate of change of tangential velocity. So I think we already know tangential velocity. So it is nothing but the derivative of 3t square. That's it. So it's the derivative of 3t square. 3 just comes outside. t square's derivative will be nothing but 2t, so this will be nothing but 6t. So that is the tangential acceleration, but we need the tangential acceleration at 2 seconds. So at at 2 seconds will be how much? 6 into 2, which is 12 meters per second square. So now the final answer. We need the total acceleration. Total acceleration will be here, correct? So this total acceleration will be the vector addition of both of them. That means if you have to write it down, this will be AC square plus AT square magnitude wise. It's just simple Pythagoras. If you bring AT here, AC square plus AT square will be the hypotenuse, which is A square. Simple vector algebra. Okay, so do I know AC? Yep, it is 7.2. So 7.2 square plus AT is nothing but 12 square. Interesting. Now the question says nearly, that means it will not be an exact answer. Let's just do a small estimate. See, 12 square is 144. 7 square is 49. If you add 144 to 49, what will you get? 144 plus 49, come on my warriors, 194 minus 1, 193 almost. Okay, now if you get 193, then think this way, when I have 7.2 square, the answer will be slightly more than 49. That means their sum will be slightly more than 193. That means somewhere close to 196. Now 196 is nothing but 14 square. So the root of 196 will be somewhere close to 14. Hence the answer will be around 14 meters per second square. So that takes into account centripetal and tangential, and in the end we just did some logical thinking to estimate the correct answer. So that's a brilliant question for you, and definitely tells you not forget either centripetal or tangential when total acceleration is asked for a particle moving in a curved path. Keep this in mind. Alright, chalo, let's move on to the next question, and there we go. Yeah, 14 meters per second square. And if you are enjoying these questions, do not forget to smash the like button, and yes, if you are new to the channel, please hit the subscribe button as well. I know you are watching this session as a recorded one, but let me tell you, my entire attention and the entire feeling as I'm recording this is as if I'm teaching a live audience. It's like I'm missing you all, but because of Diwali vacations, I had to record this session, and right now I'm not in a position to conduct the live class. But I hope you will still enjoy this class. So give it your best shot and make sure you're making notes and scribbling around as I am solving the questions. Okay, so here we have the next question. We have a particle and it is released on a vertical smooth surface. The track is given and it starts from point X, and after initial angle is theta. Okay, after some time, the particle vanishes from point Y, where OY makes angle phi with the horizontal. What is the relationship between the angles? What is the meaning of vanishing? What's exactly happening over here? Let's try to understand. See, if you have a curved surface, you keep a block. When you leave it, its speed will start increasing. There comes a point, it will just fly off. It will break contact. The moment it breaks contact at some point over here, what is happening is the contact force, which is the normal force, will become zero. So you have a smooth surface, you release something, after some time you will see it will just break contact and it will just fly off like a projectile. So that point where it breaks contact is that marked by point Y, which makes an angle phi with the horizontal. Clear till this point? Okay. Now the question is to find the relationship. Something is there related to circular motion, because obviously it's going in a curved path, so some circular motion equation must be there. Apart from that, think because it is going from a higher height to a lower height, that means it is gaining some speed. That means most likely I have to get some equation which relates the speed with the height. And you cannot use kinematics. That's invalid because the acceleration is not constant. So most likely energy conservation. When it goes from here to here, it's all smooth. So the energy will be conserved, the potential energy gets converted into kinetic energy. I hope it's all falling into place, and I hope you are able to see the bigger picture. So clearly I am seeing energy conservation in some way, and some circular motion, Newton's laws and FBD and all of that as well, because the normal force is becoming zero at point Y. Okay, so at that point Y, what is exactly happening? Let's try to draw that. So this is that point Y. This is basically at point Y. This is that mass M, and this is K. This is your radius. Okay, so your radius of that circle. Now, if I draw the free body diagram, one force will be the weight, of course. So that will be mg, and normal has just become zero. Normal has just become zero because of, it vanishes. It's clearly mentioned at that point Y. Okay. There must be some acceleration towards the center. So I will call that as AC. And yes, it has some velocity at this point. Let's say I call it as V. Okay. Now if this angle over here, if this angle is phi, this is 90 minus phi. If this is 90 minus phi, this is phi. Do you see that? Very good. What does that mean? mg has a component in the direction of the acceleration, and you can see how much that component is. It's mg is not cos phi, sin phi. So mg sin phi is giving this acceleration, so m into AC. Did you see that? There is no normal, there is no other friction or spring or tension or anything else. So only one component of mg is giving centripetal. If you are wondering what mg cos is doing, let me tell you, mg cos is actually providing the tangential acceleration. But I don't think I'm so much bothered about tangential right now, so let me just give it a miss. Okay, so mm goes off. So g sin phi will be centripetal. What's the centripetal acceleration? V square by r. Okay, so v square by r. So therefore v square will be rg sin phi. Interesting. But from this, I obviously do not get the relationship between the angles. I just got the relationship between phi and speed. Maybe I will use it somewhere, but this is the only thing which I will get using FBD, vector resolution and circular motion. Remember I told you that most likely energy conservation is also involved. So let's think about that as well. From x to y, clearly the potential energy, I can just write it over here. So potential energy at x gets converted into kinetic energy at y. So I need to know how much is that loss in that potential energy from x to y which got converted into the kinetic energy, because that will give me the speed. So I think I need that height difference between point x and y. How do I get that height difference? That's pure geometry. There is no physics in that. If you have studied your school level geometry, you will be able to get this. I just need to find this difference because this is my height h. So over here, I'm just going to write mgh is equal to half mv square. This m and this m gets cancelled. Oh, interesting. V square is rg sin phi. So half into rg sin phi, interesting, is gh. But wait a minute, I do not know the value of h. So the only thing over here, unknown over here is h. Let's figure it out by geometry. So it's simple. I'll tell you what you can do. This h is this height, okay, this height minus this height. Think about it. Okay. Now what is this height? Well, look at the big triangle over here which has angle theta. This is the hypotenuse. The hypotenuse is radius r. So it is r, what is this? R cos theta, because it is adjacent. This is r sin theta, this is r cos theta. Make sense? Great. Similarly, think what was this height. So if you're still not able to see it, let me redraw it over here probably. Okay, this was height h. Look at this. I need this height. How much will this be? Clearly you can see this triangle over here, and this is opposite to phi. So it is obviously r sin phi. So can you see H is actually speaking this height minus this height, which is r cos theta minus r sin phi, which is r common, cos theta minus sin phi. So that's the value of H, which I'm going to substitute over here. So it is r, and what did we have? Cos theta minus sin phi. Now the problem becomes interesting. Okay, you can see what and all will get cancelled. R, G and G got cancelled. 2 gets multiplied here. So it will become 2 cos theta minus 2 sin phi is equal to sin phi. Therefore 2 cos theta, take 2 sin phi over there, it will become 3 sin phi. I think I found out the relationship. So basically cos theta will be 3 by 2 times of sin of phi. So that's our final relationship. You can also write sin phi is 2/3 of cos theta. One and the same thing. Is that clear, my warriors? What a brilliant question. So what all were involved? Vector resolution, Newton's laws, circular motion, and work per energy, and a little bit of geometry, which is trigonometry. What a brilliant question. Alright, so let's move ahead to our next question, which is going to come up on your screen. Okay, so yep, that's the answer. Sin phi is 2/3 of cos theta, correct. Brilliant question coming up on your screen on banking of roads. You all know the formula for banking of roads: maximum speed, optimum speed, and when the road is unbanked, then what is the speed? But this question is slightly different. It has a twist and it has some combination of concepts. There is a turn of radius 20 meters and the vehicle's mass is 200 kg and the speed is 10 meters per second. Find the direction and the magnitude of the frictional force acting on the vehicle if it moves with a speed of 5 meters per second. Assume that friction is sufficient to prevent the slipping. Interesting. Now, remember, there is something called as optimum speed. So when there is optimum speed, that's where the road is banked for. Okay, so you bank the road for that speed. At that speed, there is no friction which acts on the vehicle. So when the road is banked at that angle and you travel at that exact speed, so what is that speed? That is V0 is equal to root Rg tan theta. This is the speed of which is the optimum speed for a road which is banked at an angle theta and there is no friction which acts on the car. When you travel at speeds higher than this optimum speed, then your tendency will be to fly off by that centrifugal force. If you travel at low speed, then you will try to skid down. I hope that makes sense. So basically at high speed, your tendency will be here. This is where your tendency to fly out will be. And because you would tend to fly out, friction is going to pull you down like this. So friction will be acting this way. This is what happens when you move at higher speeds than the optimum speed. Now let's check whether my speed is higher or is it lower. Optimum speed is 10 because that's the speed which you have designed it for, and the actual speed is less, which is 5 meters per second. So yep, the friction won't act down because the tendency won't be to fly out. It will be in fact this way. So for low speeds, my tendency, this is where my tendency will be, tendency to skid. So what does friction do? It always opposes the tendency. So you will see that the friction is just going to act over here. So that's the first catch of the problem, to figure out the direction of the friction. The moment you analyze it and mark it well, then rest of the things should be correct. Else you will definitely get a wrong answer if you assume the direction of the friction the other way around. So be careful about that. Great. So let's use this formula and see what is the value of theta that we get, because I think I will need theta to find out the frictional force. So V0 is given, that's given to be 10 meters per second, root Rg. R is 20 and then G is obviously 10 into tan theta. Let's square both sides. So this will become 100 is equal to 200 tan theta. Therefore, tan theta, take that 200 below, 0, 0 goes, it will become half. Interesting. So I got tan theta as half. So that also means one more thing. If I draw a right angle triangle like this, so maybe I'll just draw it over here. Okay, so I'll just keep it aside because I think I might need sine theta and cos theta later on. So I'll just put theta over here. This says tan theta is half. So opposite by adjacent is half. If this is 1, this is 2, how much will be the hypotenuse? Quickly use Pythagoras. 1 square plus 2 square. That's 5, root of 5. So this hypotenuse will be root 5. The advantage of this triangle is it helps me calculate any other trigonometric ratio. Just because I know one of the trigonometric ratio. So from tan I can calculate sine, cos, sec, cosec, whatever I need to. Okay, so this job is done. I think I figured out the value of tan theta. I don't need this anymore. Okay, now let's draw the rest of the free body diagram. Because the question says, figure out that frictional force. You'll be like, sir, why are you wasting your time? Just write it as mu n. No, it is not mu n. Reason, who told you that this friction is limiting friction? It's just that a friction force is acting on it. It's preventing it from slipping. It's not traveling at maximum speed or the least speed for the friction to be, limiting in nature. So clearly F is not mu n. So take that out of your head. Okay. And next thing, apart from the normal force, try to understand that, okay, let me just draw that normal force first of all. There is a normal force over here. There is mg like this over here. There is also another force, and if you sit in that rotating frame, if you see that car going in that curved track along the banked road, you are in a rotating frame, so it's non-inertial. That means centrifugal force outwards. So there will be a centrifugal force Fp, which is going to be mv square by r. And because you are in that rotating frame, you will just see the car at rest and the rest of the world revolving around you. So this entire system is at rest in the non-inertial rotating frame. Okay, that's the reason why I have used the pseudo force, which is centrifugal force. Everybody clear till this point? Okay, let's go ahead. Okay, so I think it's just about vector resolution now. I think you can see that very clearly over here. So let's talk about only the forces in this direction. I know this is angle theta. So if this is angle theta, this is also angle theta, you can see that. And if I just draw a perpendicular, this is theta, this is 90 minus theta, this is theta, and this is 90 minus theta. So obviously this is theta. Okay, so along the incline, here is what I can say. Along the inclined plane, the net force must be 0. Why? Because it is at rest. Clearly, we analyze that situation. So all the forces up and all the forces down should cancel out because the car is not going up nor going down. It might have a tendency, but it is not actually going. Okay, the friction is preventing it from moving either up or down. Okay, so the frictional force upwards plus the pseudo forces cos component, that means mv square by r's cos theta component, will be balanced by mg cos is here, mg sine will be down the plane, will be balanced by mg sine theta. If you don't like to put it on the RHS, it's okay, put minus mg sine theta. This will be the total force. This should be equal to 0. This will make it look very correct probably. Okay, so we need to find out F. I think I just need to substitute everything. So let's just do this. So F will be mg sine theta minus mv square by r cos theta. Great. So what is m? Mass is 200. G is nothing but 10. Sine theta. This triangle will be helpful now. Sin theta is opposite by hypotenuse. That means 1 by root 5. Minus mass. How much is it? 200. Okay. Velocity. How much is the velocity? I think it is given. It moves with the speed of 5. So this will be 5 square. Divided by radius. How much is the radius? It is 20. Into cos theta. Cos theta is adjacent by hypotenuse. That means 2 by root 5. Interesting. So let's see this. This will become basically 2000. Root 5 is common, obviously, from both places. And you can cancel out few things. Like this will go, this will go, this 2 will go, this 2 will go. Okay, so what do we have over here? Minus 5 square is nothing but 25. 25 into 2, that's 50. So that's 500. So minus 500. 2000 minus 500 is 1500. So I'll get 1500. I can rationalize it also. 1500, I can write it as 300 into 5 divided by root 5. Okay, that's fine. Root 5 goes. So I'll just get 300 root 5, and that's the frictional force. That means it should be in Newton. So that's our final answer. This is our final answer. Done. So lots of concepts. Like I told you, there was a twist and you had to figure out the direction of friction properly. If you made a mistake there, then all your equations will be wrong. Okay, so instead of assuming up, if you had assumed it down, you'll get wrong things. And you know, the idea that the optimal speed will give us the angle theta, and that angle theta will also give us the other trigonometrical ratios, which I used it over here, like sine and cos. So that's very challenging, and I hope you enjoyed this question. Okay, so let's move on to the next one. 300 root 5 Newton, and we got it upwards. Yep. Now, if you have any doubts, let me tell you, in Vedantu, we have a doubt facility where you can ask any doubt. You can send in screenshots, and you can also chat with our subject experts. And there are individual subject experts who sit just for you from morning till night and on all the days, so that you can ask any questions from any of these subjects and you can get your doubts clarified, rather than Googling it or asking some random person, and then there is no guarantee that the solution might be correct. So make the best use of it, because it is completely free of cost for all the Pro Plus and the Pro Classic users. Alright, so let's go with the next question. There is a projectile which is thrown at an angle theta with some speed u. Interesting. Find the radius of curvature at the point of projection, that means here, and at the highest point. Now I know many students or many places I have realized that you learn some complicated mathematical formula for finding the radius of curvature. See, if you try to go via that method, that means you are killing the beauty of the problem. You are no longer learning physics, you are just learning mathematics. So yes, maths is fun too, but when this question is framed, I think the paper setter or that person who designed this question would have thought about this problem from the physics point of view. So let's try to analyze the problem from the physics point of view. See, whenever you have any curved path, okay, any curved path, each of that curved path is made up of small arcs. If you extend that arc, you will get a circle like this. If you extend that arc over here, you will get a circle here. If you extend that arc over here, you will get a circle here. These are all instantaneous circles for the particle traveling in that path. And you can see they all have different centers. Obviously, every circle will have a radius. So this is the radius for this circle, this is for this circle, this is for this circle, this is for this circle. What are these radius called? This is called as the radius of curvature of that path. What is my idea? The idea over here is any curved path is actually circular motion, but of different circles. So any random curved path you take, it's actually doing circular motion for this circle. The next instant it is doing circular motion for the other circle of different radius, different center, and it keeps changing from one circle to the another. So basically, you can use the concept of circular motion for any curved path. Now remember, this is a projectile motion. So actually the path is a parabola. It is not even circular motion. But that parabola is made up of small arcs. And one such arc is probably going to create a circle right over here. Can you see that? So there is going to be a circle right over here, and the question which is asked is, what is that radius of curvature? So let me just draw a better circle. Okay, so maybe something like this. Okay, so this is the circle. Okay, and that is at that instant. The arc is over here at that instant. So what I need to find is this radius. How do I do that? It's very easy. Just remember one formula, and that is centripetal acceleration is velocity square divided by radius. This arc is the radius of the curvature of that circle. That's what it is. Okay, so I need to figure this R1 out. I can do that. I'll tell you how. See, this is theta. Okay. The only problem is I do not know what is the centripetal acceleration. Treat it like circular motion and see if there is any acceleration at all for that particle. We all know any particle which is thrown, it always undergoes only one acceleration, and that is acceleration due to gravity. And where is acceleration due to gravity? Come on, my warriors, think about it. Where is acceleration due to gravity? Acceleration due to gravity will be downwards like this. Correct? So acceleration due to gravity will be like this. This G will have two components. One component over here and the other component over here. This is your tangential acceleration. This is your centripetal acceleration. Why? Because a component of the acceleration which is passing through the center should be the centripetal acceleration, and the component which is tangential to the circle should be obviously the tangential acceleration. So I have taken that acceleration, split it into two components, and then assigned them the names. So that's the method to find the radius of curvature. Now it's pretty simple. See, if this is theta, obviously this is 90 minus theta, this is theta, and this is again 90 minus theta. So obviously this is theta. Remember, this was 90 minus theta. So what is this component going to be? You can easily figure that out. That will be G cos theta. This would be G sin theta, but I don't care so much about the tangential one because I want centripetal. That's it. Now try to solve the question. So what you will say using this formula is the centripetal acceleration is nothing but G cos theta. Remember, this will always work. The moment you have any path, right? The moment you have any path, there will be some acceleration. Just split that acceleration into two components. That component which is towards the center will be your centripetal, and just write it as V square by R. You know this, you will get this. That's the way to find radius of curvature. Is it now clicking? Let's do this. Okay, so what is the centripetal acceleration? It is G cos theta. And the velocity is u square by r1. So therefore r1 will be u square by g cos theta. So that's your first answer. So at the point of projection is done. The only problem left is at the highest point. That is also easy. Same logic. Again, just visualize an instantaneous circle right over here. Okay, just visualize an instantaneous circle right over here. Okay, it will not be the height. Okay, a lot of people say that, sir, it will be the maximum height. No, it's not maximum height and all that. Okay, it could be anything. Now this is the circle, this is the radius. Okay, just 1 second. Okay, so this is the radius. Let's say I call it R2. Now think, what is the acceleration at the highest point? G. Where is it? Down. Acha. Interesting thing is, I don't have to split G now. It's already towards the center. So this G itself is the centripetal acceleration. In fact, there is no tangential acceleration at the highest point. It has already reached its minimum speed at the highest point. So there is no tangential component. Interesting. But there is some velocity at the highest point, and we all know at the highest point the velocity is not u, but it is u cos theta. Why is it u cos theta? Because the vertical component vanishes, the horizontal component still stays at the top. And you can clearly see the velocity is perpendicular to g. So that's it. All you need to do now is at the highest point. Again, use this formula. The centripetal is exactly g. The velocity is u cos theta. So just square it divided by r2. So what will r2 be equal to? It will be u square cos square theta divided by g, and that's your second answer. Done. So whenever you see a question on radius of curvature, what is your first thing that should strike you? First, find the total net acceleration. See where is it? Split that acceleration. One acceleration component will be along the tangent. One acceleration component will be perpendicular to the tangent towards the center. If you want, draw a hypothetical imaginary circle. The component of acceleration which is towards the center is what you need, because that will give you the radius of curvature. And you should obviously know the speed at that point. Yes, without the speed you cannot get it. And most likely you will get it by some or the other way. Interesting question. Alright, so let's move ahead to the next question coming up on your screen. Okay, I'm not sure why is it not moving ahead. Okay, yep, now it's fine. Okay, so we have a particle of mass m, and it is moving in a circular path of constant radius r, such that the centripetal acceleration is varying with time. Interesting. The centripetal acceleration's magnitude itself is varying with time. K is a constant. Find out the power which is delivered, to the particle by the force acting on it. Very, very interesting. Let's think. So we have a particle which is going in a circular path. Obviously it will have some speed, correct? And it also has some radius like mentioned over here. Question is, find the power. Interesting. Now there are two kinds of forces. One is the tangential force, one will be the centripetal force. My question to all of you is, out of these two forces, tangential and centripetal, which force will be doing work? Or both will be doing work? Is it the tangential? Is it the centripetal? Think carefully. Work is force, displacement, cos theta. Only the force which is along the displacement will create work. Centripetal is perpendicular to the velocity or the displacement, so it will not do work. So that's the first point. Centripetal, doesn't do any work. So basically that power is coming by the work by the tangential force only, none other than tangential force. That's it. Okay. Now what is power? Power is force dot velocity. Okay. So if it is force dot velocity, I do not know velocity, I don't even know the force. So I think I need to find that out using this equation. Okay. So eventually I'm just going to do this. Power is force into velocity. And I don't know any one of them. So let's do something to get it. Let's see what we can get from this equation. What is centripetal? K square R T square. So try to use your mathematical brain, manipulations. It's all about manipulations. See what do you want, see what is given. Think what and all we can do. Let's just start with this equation first. AC is equal to K square R T square. What can we do? I think we'll just go with the formula. What is the formula for centripetal? V square by R. Okay, let's just write it. So I just got V square by R is equal to K square R T square. So V square will be K square R square T square. Interesting. So if I take square root on both sides, I'll get V is equal to K R T. Acha, I think I just got velocity. Yeah, the speed is K R T. Okay, so one term done. So the only thing remaining is force. Okay, how do I get force? Think. Force is nothing but mass into the tangential acceleration. Okay, what is tangential acceleration? Rate of change of speed. Yep, so let's do that. The tangential acceleration will be dv by dt, rate of change of that speed. So it will be nothing but k and r are constants. So dt by dt, that is 1. So it will be just kr. And that's your tangential acceleration. Everybody clear about this? So I got 80. I think I can just substitute it over here. So this m as it is, tangential acceleration is just kr, and this speed is krt. So this will become m k square r square t. So that is your power, and done. So seemingly difficult problem uses little bit of calculus, just partially, little bit of mathematical manipulations, and also the concept of work per energy, where you need to understand which force is doing work, which force is not doing work, else you will definitely get a wrong answer. Okay, so a lot of concepts involved, and that was this question. Moving on to the next one. Yes, that was the answer. So we have a ball which is suspended by a thread, and it swings in a vertical plane so that the magnitude of the total acceleration at the extreme position and the lowest position are equal. Find the angle which the thread makes at the extreme position. Interesting question. Okay, and we are going to have fun solving this question, let me tell you that. Okay, so we have this thread, and let's say this is the extreme position, and eventually the thread will come below somewhere like this. So this is the path taken by the pendulum. This is angle theta. Okay, so the question says the acceleration at the extreme position is same as the acceleration at the lowest position. Now first think this way, since it is going in a circular path, obviously it will have centripetal and tangential accelerations, right? Any circular motion usually has centripetal and tangential, but there could be possibilities that tangential is not there or centripetal is not there. Let's just figure out what is happening in this situation. Okay, when you just release the ball, because at the extreme position means this end or that end, what happens? It just stops, turns and comes back. So at that position it has just stopped for a moment. So obviously velocity is 0. If a velocity is 0, think v square by r will be also 0, right? So v square by r will be 0. So centripetal will also be 0. Is that clear? Centripetal will be 0. That means at that particular location there can be only one kind of acceleration, and that is nothing but the tangential acceleration. So definitely there is going to be some tangential acceleration here. This tangential is the total acceleration. There is no centripetal at that point because speed is 0. Wow, that's good. We have saved a lot of time, calculating centripetal and taking the vector addition and all of that. What's happening over here at the lowest point? Think. There is one mg force down, there is a tension up. There is no force horizontally. Number one. That means there is no reason for the tangential acceleration to be there. Well, if you did not get it, I'll prove it to you other way around. See, when it comes down, the speed increases. After it comes down to the lowest point, after that, the speed decreases. So this is the point where the speed stops increasing and it starts decreasing after that. Till this point it was increasing, after this it starts decreasing. So acceleration, tangentially goes from positive to negative. If you have to go from positive to negative, you have to cross somebody. Who is that somebody? 0. You cannot just jump from positive to negative. You have to cross 0. So therefore, the acceleration at that point along the tangent should be 0. Other way of looking at it is the force of tension and force of gravity is only along the y-axis. There is no force in the x-axis. So there is no reason for having any acceleration in the x-axis. So clearly the acceleration is only and only centripetal in this case. And I can mention over here that at is 0 since velocity increases and then decreases at this point, and all forces are in the vertical direction. Interesting. Okay, let's just figure this out now. Okay, so here there will be some velocity obviously, and because of this velocity, this centripetal acceleration will be v square by the length of the string. Very good. So what is asked in the question? This centripetal and this tangential both are equal. That's what is asked in the question. So I think we need to find this V, we need to find this AT. Okay, let's start quickly doing this problem now. So let's find AT first. If you think about it, tension will be here, mg will be here, and this is theta. So naturally this will be also theta. So this is perpendicular. So you can see over here, mg's sine theta is providing tangential acceleration. So mg's sine theta is mass into tangential acceleration. So tangential acceleration will be just g sine theta. This is one thing which I got. Fair enough. How do I find centripetal? For that I need v square by r. But how do I find v square? For that I need to use energy conservation. Wow, crazy. So let's use energy conservation because the potential energy has got converted into kinetic energy. That means I need the height difference. That means I need to drop a perpendicular. So I just need this because mgh has got converted into half mv square. So the potential energy at this location got converted into kinetic energy. How do I find this h? That's also easy. This whole length is L. This whole length is L. This is also L. This is a 90-degree right angle triangle. So in this right angle triangle, if this is L, think this way, if this is L, how much will just this much be? This will be L cos theta. So how much will this h be? L minus L cos theta. Do you see that? So therefore this will be mg L minus L cos theta. So L minus L cos theta is equal to half mv square. Mm goes, L comes outside, Lg 1 minus cos theta is equal to v square by 2. Interesting. So I just got v square from here. So it is 2Lg 1 minus cos theta. So from this, I'm going to go back to the centripetal acceleration. So centripetal acceleration is v square by L. So therefore it will be v square by L. If I do that, it will be 2g 1 minus cos theta. Very good. Now, once I got this, the last step is equating tangential and centripetal because it is given that the magnitude of total acceleration at extreme and lowest positions are equal. So let's just do that. Since it's given in the problem, centripetal is equal to tangential. Centripetal at this point is tangential at that point. Okay. So centripetal is how much? It is 2g 1 minus cos theta is equal to g sine theta. Acha, gg goes and we have 2 into 1 minus cos theta is equal to sine theta. What to do now? I just can't get the angle so easily because no matter what I do, I will always have some sine or cos. So think mathematically. Physics is ended. Physics is over. Yeah, now think mathematics. Can I do something with it? Yep. 1 minus cos theta. Does it remind you of some formula? Just see if it reminds you of some formula which you have studied back, in trigonometry. So you had cos 2 theta, okay, is 1 minus. Think about it. 1 minus sine square theta. Yeah, 2 sine square theta. Yep. Is that the formula that you have learnt? Think about it. So if you have learned that formula, then you can just shift this around. So 1 minus cos 2 theta will be 2 sine square theta. Think about it. So 2 sine square theta is 1 minus cos 2 theta. So use the double angle formula technique and just apply it over here. So instead of 2 theta, I have theta. That means actually what I will get is, instead of 1 minus cos 2 theta, I have 1 minus cos theta. That means on the LHS, which was 2 sine square theta, I should get 2 sine square half of that angle, which is theta by 2. Is that clear? It's just double angle formula. 2 sine square theta is 1 minus cos 2 theta. So 2 sine square theta by 2 will be 1 minus cos theta. That's it. Is equal to. This also I can use some double angle formula. You have learned this. Again, sine of 2 theta is 2 sine theta cos theta. Haven't you learned this? So just use that. Okay, so but here you have sine theta. Again use the same technique. If it is sine theta, it will be 2 sine theta by 2 cos theta by 2. So everything becomes half. So it will be 2 sine theta by 2 into cos theta by 2. Okay, what and all will get cancelled, my warriors? 2, 2. Sine square, sine. Interesting. So 2 sine theta by 2. I can just write it as 2 sine theta by 2 is just cos theta by 2. Take cos below, take that 2 there. So tan theta by 2 is half. So theta by 2 is tan inverse of half. Take that 2 there. So therefore theta is 2 tan inverse of half. I think that should be our final answer. What a beauty. Did you enjoy this? I mean, what was not there in the question? We started off with, now please don't say, sir, please explain again. Just watch the recording. Just go behind and start from again, okay? I'll give you the gist. Because the accelerations were equal, I just figured out at this point, since speed is 0, centripetal is 0. It only has tangential. And using Newton's laws, I saw mg's component is giving the tangential acceleration. I found 80. At this point, this speed is giving centripetal, there is no tangential acceleration. In order to find that speed, I used energy equation. So potential energy got converted into kinetic energy. So from that, I got the speed over here, which enabled me to calculate the centripetal acceleration. Last step was equating centripetal and the tangential, whatever I got. Solve it. The physics part ends over here. After this was mathematics using your double angle formula. Okay, and that's it. You just do some manipulation and you get the answer. Beautiful question. If you have enjoyed this class, I mean, like, really, hats off to you. And this is how it should be. You should always enjoy physics. You should always enjoy the maths. You should always involve the manipulations and the fun around those equations and those laws, which build those equations. So I have a homework question for all of you. Please drop in all the answers in the comment section below. I would be eagerly waiting to see how many of you are able to solve this question. Trust me, it's not very difficult. Okay, so just try to solve this. And if you are interested to take up my courses, if you want to solve more problems like this, I am also teaching in the pro subscription, and there are many other teachers just like me. You also have long-term batches in English, and my micro courses will help you, solve problems of HC Verma. Then there is an Irorov course. Then you also have problem solving course. Then you also have derivation course for 11th standard, and all these amazing questions with theory, with derivations will build your confidence in physics. And there are many more things like KPI course and all the auxiliary courses that you would need along with tests and assignments. So all of this, you get it at a very affordable price. In fact, everybody should try it. You will see in the description box below, there is a link. When you open that link, it will show you all the plans like Light, Classic, Plus. Light gives you all the things like notes, study material, test series, and live classes, recordings, etc. In Classic, you get the doubt solving on the mobile app, so you might need some help after the class. And in the Plus version, you will get a personal guide, personal tutor, personal mentor who will help you throughout your journey. And the lowest plans start from very, very less price. This price is actually before that discount, there is now an offer going on where you get a trial for 15 days. This was the old price. This was per month. The trial price for 15 days is even lesser than this, almost half of this. And when you try for 15 days, you get additional 15 days free. And over that, you get 10% off. So it comes very close to some 1,350 rupees, in which you get the entire month subscription at the cost of 15 days along with 10% off. So just try out, use the coupon code SHHPRO, and do recommend this in case somebody else needs this coupon code for getting discounts at Vedantu, because these are the highest discount coupon codes that you can get, no matter from where else you try. Alright, so I hope you have enjoyed the session. Do not forget to subscribe in case you haven't done it. Share the channel and promote this channel in case you find students who need this. And yes, do not forget to give your Guru Dakshina by smashing the like button out there. Okay, so stay tuned. More problem solving sessions, more lectures are coming in the nurture series as well. That's it for today. I hope you guys have enjoyed this session. Tada, bye bye, take care and stay safe, and wish you all a very happy Diwali once again. This was Captain Shreyas. Hasta la vista.